All right. Again, my name is Mica Block. I'm director at a group at OpenText. We're leading technologists that are part of the sales organizations. We do proof of concepts, and we do all the fun technology stuff. I'm originally not from New York, but I've been living in New York for the last 25 plus years. As such, I'm somewhat opinionated. Like to share my opinions, which is the main reason of this presentation. When it comes to data visualizations, there's no one right way of doing things. A lot of the things I will share today are my opinions. Feel free to disagree with me, or if you have any questions, feel free to do so. It makes this whole presentation a lot more interesting. And I've been dealing with data visualizations also for about 20 years now, so most of the stuff is based on my experience or what I've learned from other experts. Two specific experts that I'm going to talk about during this presentation. One is Edward Tufte. Has anybody heard of Edward Tufte? Yeah, good. So hopefully that's not new. And another one is a gentleman by the name of Stephen Few, who's more modern, does more on dashboards and stuff like that. Anybody hear of Stephen Few? Okay, so a lot of this stuff then shouldn't be too new. So what we're going to talk about is two main topics. One is why do charts work? And the other things is how can we make charts work better? At the end I'm going to show some examples of some visualizations, some of them good, some of them bad, just like everything else. Okay, so the first topic is why do charts work? So visual encoding of data for rapid perception, we see with our eyes, but we comprehend with our brain. So even though the physical seeing is with our eyes, what we perceive is in our brains. Eyes are just a sensory mechanism, but our brain is where our perception occurs. Classic example, a couple of months ago, there was that whole thing with the blue, gold, black, white dress. Our eyes saw one thing, and in the actuality it was something else, and that is the same thing with charts. Another example of that is, can somebody tell me how many number 5s are here? Well, there are some. How about now? Actually 7, there's one in the title, but we won't count that one. So why was it easier for us to see this versus this, right? And the reason is because our mind perceives shades better than they perceive shapes. That's what it is. It's the way our brains work. So what we're going to talk about is the difference between attentive processing and pre-attentive processing. Attentive processing is when I have to pay attention, look at what I'm looking for, and then trying to understand what it is, whereas pre-attentive processing is where I see things immediately, where it works. So the first example is complex shapes. That's an attentive attribute. The second example, which was when we highlighted, which is a shade intensity of a color, which is a pre-attentive attribute. We're much better at detecting shade than we are at shapes. So, what are the pre-attentive attributes? There's actually 4 of them. Color, form, spatial position, and motion. Last one not really applicable to charts, only in very specific scenarios. But we'll talk about those 4 attributes. So color, there's 2 types of color. One is hue, what color, blue or red. And then there's the intensity, darker versus a lighter shade. When it's form, there's a bunch of them. One is the shape, squares versus circles. The size, a smaller circle versus a larger circle. The line length, the length of a line or the thickness of the line. These are all different pre-attentive attributes. Some more forms, orientation, angle, so if something's actually a little bit different, enclosure, and then added marks is also another form of shape. And we'll talk about in a minute that all these different attributes work differently. And then the third one was position. The key one there is 2D location, right? It's probably our most effective pre-attentive attribute. We think, and especially in the 2D, where scatters, lines, bar charts are all on a 2D chart, a 2D location, something's higher or lower, wider or left or right. We see those very clearly. And then motion, and the motion could be a flicker, it could be anything. Not very applicable to charts, very applicable to our ancestors who were hunters. They see something flickered in their range of sight, and then they went the other way, or they went towards it. Depends on what they were trying to do. There are some motion charts that are okay to use, but they're very rare. When one classic motion chart is, think of a chart over time, so it's like kind of moving bubbles or moving lines. So if you want to see growth over time, there's certain aspects of that, and I'll go through some examples where motion might be okay, but in general, it's really not applicable to charts. Another important point of it, not all pre-attentive attributes work the same way. A larger square is greater than a smaller square. Is red greater than blue? Probably don't know, right? That might or might not be the case. So there's two types of pre-attentive attributes. One is a quantitative. So 1, 2, 3, 4, small, medium, large, so things are bigger than something else. And some of them are categorical, apples, oranges, sales of different items. So those are categorical, apples, oranges. So for the quantitative, something can be larger than something, and in categorical, they're just different. So there's different things you want to measure. More detailed examples on that. So quantitative things could be color intensity, size, line length, line thickness. Those are quantitative, whereas categorical would be things like hue or shape. These are just things that are different. Enclosures or added marks, these are to define something that is different. How many values can we distinguish, can we perceive when it comes to differences in colors or something like that? Guess anyone? Close, but it's actually 5 is pretty much the limit. There are certain exceptions, but they're very rare. But it's about 5, and it's applicable color whips, pi wedges, distinct lines on a chart. Anything more than that, it kind of defeats the purpose. And we'll show a bunch of different examples on that. The exceptions are colors, but again, not more than 9. And then 2D location. So I could have more than 5 bars, and I could still distinguish the difference between them. So if we want to talk about the specific charts that we have there in the world, why does a pie chart work? So it has angle, it has size, and it has sometimes hue, different colors of the pie charts. A bar chart, it has size, so it's the length of the bar. Hue intensity is sometimes optional, but also the 2D position. Line chart, the 2D position. Scatter charts, again, 2D position, sometimes hue intensity, maybe some added marks. Text table is actually a visualization. It's actually a very good one. One of the reasons why tables work is because I could actually put a lot of numbers in a fairly small area. And when the number is what you want to show the damn number. Sometimes the number is what is important, show the damn number. I can do some added marks like arrows if it's trending up, or we'll talk about other types of visualizations like spark lines that can actually show a trend. But tables are actually very good visualizations. Bubble chart, again, size and hue, and again, 2D position, and even things like a network graph, and this again, it uses a 2D position and added marks. These are the reasons why these type of charts work. Questions? I'm talking, yes?
Well, you're talking about charts, and there are other kinds of visualizations.
Correct, and I'm going to talk about some of them also. All right, we'll talk about that, yeah. So using charts better. So Edward Tufte, he's pretty much probably the grandfather of data visualizations. He has a lot of very specific ideas on a lot of things, and one of his main, he has 5 grand principles of visualization. One of his main ones is to enforce visual comparisons. When you actually build charts, you want to have he's very fond of having multiple of smaller charts that kind of show the visual comparison. This one on the left is actually a very good example. This is showing fuel consumption. So there's laws in the US now which every car company has to have across their fleet of cars or sales a minimum of mileage per gas mileage per gallon. How many miles per gallon? And basically you'll see there's a black line across all of those and how they're going across the line, and somewhere around 2010 that line has grown up. So the law is actually across the fleet they have to get more and more. And it kind of shows the different car companies. So because all the car companies are shown line by line, you can actually see Toyota compared. So you could see Toyota and Honda, obviously they're above that. They've always been above that. GM is teetering on it, Ford is teetering on it. But you could see which other companies have been very good at it. Porsche, completely underneath it. They don't really care, I guess. You know, and BMW, the same thing. So there are different companies have gone. But because I see this across multiple variations of it, I can reach my own conclusions on that. Stephen Few, he has also some core design principles for displaying quantitative information. Display neither more nor less than what is relevant to your message. Which chart do you like better? Right or left? Just point. You guys are good. So typically, if the average person who probably is not into data visualizations, they'll say the one on my right, because it's prettier. Part of it is distracting. The big no-no on this is 3D. In general, in 3D of charts, so if you actually just look at that chart, can you tell me what's the number for theme parks? You can't. It is actually 3.5, but because of the angle, because it's angled here, you can't really see. Can you see, tell me what the number is for world tours? No, you can't. It actually, the 3D distorts completely the numbers that you're actually looking at. And the fact that they have that junk in the back is something we're going to call chart junk, and we're going to talk a little bit more detail into that. His next principle, don't include visual differences in a graph that do not correspond into realistic comparison. So in this case, you could see that there are slightly different colors on the different charts. What are we charting here? We're charting here travel trends, average profit 2013 in billions of dollars. What we're charting is exactly the same. They should be the same color. There's no difference between world tours and theme parks. In this case, we'll talk about cases where I do want to change the color because I have a good reason to do so. Differences in values should be portrayed accurately. These two charts are showing exactly the same number. In the chart on the right, on my right, cruises is actually a very small chart. So if I was in the cruise industry and I wanted to go to government and ask for a handout or from tax benefits, I'm going to show the chart on the right and say, oh, we are poor cruises, we're not making a lot of profit, please help us. Whereas in reality, they're not too bad. What's the difference between the two charts here? The scale, where we're starting from. So because I'm distorting it, so I'm starting at 2.4, it looks like there's a big difference between cruises and the rest, when in reality, the difference really isn't that big. In general, all bar charts that are quantitative should always start at 0. All bar charts. Line charts, not so much, but bar charts definitely. Because what I am looking at is differences in values. Okay. Next one, do not connect values that are discrete, suggesting a relationship that doesn't exist. Northeast, north, south, east, west. There's no trend here. Don't use lines when it's not appropriate. We'll talk about when to use which charts in a minute in more detail. Emphasize information that is most important to your message. I'm going to stress this a lot during the next section of this presentation. Every chart tells a story. Depending on the story you want to tell, there's an appropriate chart for that. But more importantly, there's also the appropriate way of telling your story that makes it more compelling. And this is an example where I do want to change the color because it's part of my story, right? So these are stocks, gain, losses, and I want to emphasize the one that had greater than 2% loss. Last time I did this presentation, I was actually in a Cisco building. It wasn't really that good. I didn't even notice it until so it says, this is Cisco. So apparently they didn't have a good year. So. And here's the big question. So what visualization should I use? And then there's a lot of different visualizations, and I'm going to go into examples in the end. The first part of this will just be the standard visualizations, when I should use what. So one is bar charts, obviously. I should use horizontal bar charts when there's long labels, when there's a pattern comparison, so I'm comparing in this case I'm comparing two different things, longish lists, vertical when I want to do groups within groups, stacked or multiple series, when I want to do Pareto charts. It really doesn't work with large number of groups because there's a limit to what I can put there. And of course bars can be easily drilled into, so that makes it a very appealing type of chart. Again, it's the old standby. It's easy to compare heights. Can be used part to whole, like a pie even. Also useful from comparing discrete values. Again, use colors judiciously, only if it's different series. Do not use it as the same thing. Use vertical as a rule because our eyes actually compare height better than width. Again, it's these are facts of our brains. We do compare height better than width. So as a rule, the default should always be vertical. You should use horizontal if it's a longer list or for readability, right? So if what's important that I want to read, the names are maybe slightly longer or they're going to be cut off, never rotate. Our eyes can't read it. If you have to rotate the labels at a 95-degree, 45 or 90-degree angle, flip the chart. Must start at 0. Again, never, ever, 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 ever use 3D on any chart. So here's example. So again, this is a bad example, and this is on purpose bad. So we're going to see what we can do to improve this chart, right? So there's different colors here with labels and legends and 3D and all kinds of garbage here. So the first thing we want to do is we want to get rid of the 3D, right? So it's a little bit better. The next thing we want to do is we want to clean up the lines. And we'll talk about this concept of data-ink ratio, another one of Edward Tufte's favorite lines. The next thing we want to do is we want to put, instead of making a legend, we want to put the labels on there. Lastly, we can actually put the numbers on top so we could get rid of the axes directly. This is another option. And then why do I want to sort it alphabetically? It doesn't make sense. It's a lot easier to distinguish charts if I sort it by amount. right? And then it makes it more easily to read. And lastly, if what's important for me to read is the x-axis labels, then I could also do it as a vertical line, but only if what's important is the actual labels, because it makes it easier to read. So very easily we came from one ugly chart, and we got 3 different versions of good quality. This one's good, and no, you don't have it. So I could actually even live with this if it was sorted by the amount. The other good chart to use is line charts. Again, it's the old standby. Shows trends over time. It's less useful for discrete values. I don't really care about a specific value. What's important to me is the trend. Again, in this case, you don't need to start the scale at 0. Best to label lines directly, not with a legend. Yes?
No, I'm saying when you see values which range so large, like in the last one, we have very large values and very small values. What about adjusting the scale concept?
Do not do that, because then you are distorting the truth. Never break it out. Like you'll see some charts, sometimes what they'll do is they'll break the chart, right? That's one way of doing it. I'll give you an example of
I mentioned also like logarithmic.
a logarithmic. Unless you're a mathematician, that
Logarithmic scales can be very useful. Sometimes you're going to have a disparate difference where you're dealing with like something that's 200 million, something that still is valued that's 10 million. If you're trying to represent it as 0 value, you can't do it with
the truth of the matter is that it will be good if you understand a logarithmic scale.
Yes, but I have to make an assumption that if I can't actually explain it, then I can explain it to my user.
You have to be very careful. I'm not a big fan personally of that. It really depends on the chart. So if I actually, what are you charting in those areas, right?
Depends what you're dealing. I mean, for me, I deal with billions and billions of petabytes of data. So if I'm dealing with that much data, you actually are going to deal with this. You may have something that's newer, that's growing or something, and the increment is important to watch. But if you're doing it, if you comparison with something that's live for a long time, you won't even see the
You won't even see the measure. I would prefer things like callouts or asterisks to actually show that there's data, because for our human perception, again, goes back to our perception of what we're seeing. The fact that it's a big difference is part of the story.
But it's really important to reveal the data to the end user, and then sometimes you have to bend.
So I would rather bend to the idea of doing callouts than bending on a logarithmic scale. That's, again, I like your idea, yes.
I was going to say, it depends on the audience.
Correct.
Let's say your audience are engineers.
Then I could use a logarithmic scale, right? That's very rare, though. And this is actually an interesting chart because there's some good and there's some bad in this chart. So this chart is, I don't think you could read it. So this is Germany's unemployment rate actually decreased during the crisis when the government instituted a short-term program and subsidized. And basically what they're comparing to is Germany to United States. So Germany is the red and United States. So since the chart is going from 2008 when we had the financial crisis to 2011. So the unemployment rate in Germany went down and US it went up, and that's what he's emphasizing in this chart because there actually are too many lines in this chart. So he's showing other outliers here and he's kind of putting that in the background. Some of that is, you can understand that some of it is good. So there's other countries, Austria, Belgium, over here, they're doing okay. And the top ones are the obvious ones, Greece, Ireland, and Spain. So these are the countries that are in trouble with the financial crisis. So it's actually a very interesting chart. And he's doing a good job at emphasizing his story, which is comparing Germany to US while showing other pieces of information if you do so the pre-attentive is the Germany and United States, the rest of it is attentive.
Good question.
Yes?
So why is the improvement in red and then the improvement is also lower on the scale?
The red is because I'm thinking he's doing negative numbers in red, in this case.
What does red usually perceive as
Bad.
Bad and or lower on the chart is also bad? So
I would actually do, you're right. In this case, unemployment rate is bad. I would use red. Red in general in charts is bad, green is good. So I would expect that the guy chose the color red, because, not my chart, because neg is usually a negative number. Yes?
I think you have to be aware of the cultural context. Right? Because different meanings-
Yes.
Colors have different meanings.
Ooh, that is very, very true. And there's a lot of things that you can do in certain cultures, certain colors you shouldn't be using. Don't wear brown suits in Japan. Just don't do it. So if anybody ever travels to Japan, remember that one. So the bottom line is, every chart tells a story, right? So again, going back to the attentive versus the attentive attributes, line charts are trends over time. Bar charts are comparing discrete values, right? So you use a bar chart if it's categorical, you use a line chart if it's trends over time, right? The top chart is showing different months, if you haven't figured that out. And if I'm doing months, bars is not the way to go, because you want to show the trend. It's a lot easier to see the trend in the line than it is in bars. Some other data visualizations that are also very good. Spark lines. Spark lines are small lines that show trend. So if I actually have a table of information and I want to show trend, other people that do this, I don't particularly like the bars. This one is something called a bullet chart. It's an kind of invention of Stephen Few, and the way the bullet chart works is this is the number that I'm looking at. So there's different colors. This is a target line, and the different colors will be different aspects of red, green, blue, things similar to what you would see in a color line. So it's a lot ways to different. So in this case, these are the targets. Anything above the target is green. Below here is kind of bad, and this is where I am, and this is where I'm going. It's a fairly easy chart to understand if you see a bunch of them. Small real estate. A lot of the things that Stephen Few does is small charts in meaningful charts in a small piece of real estate, especially with dashboards. You want to include, in many cases, a lot of information in a single screen. Tables, again, they are very good visualizations. It's good for specific values. Excel displays simple relationships. Again, if you're using tables, use other things to actually show things like trends and spark lines. It has a level of precision that you don't have in charts. Again, add arrows and highlights. Online, if you're actually viewing some of these tables online, a lot of times you could sort on them. You click on the column header, you could sort on it, filter the data. You could sometimes play with the data depending on the tools that you're using. But again, it's a very good visualization in certain scenarios. Tables are more on the attentive attribute because you really have to read sometimes the numbers. Maps, one of my favorite ones. I'm going to go a little bit more detail on this specific map. Use appropriately. The whole point of maps as visualizations is it's good for demographics. It's good for certain things that are geographical in nature. It can be useful for regional components. I'm not a big fan. A lot of times you'll see maps, and then they'll put charts on top of a map. So on the US, let's say on Atlanta, they'll have a chart of a pie chart on the demographics of that area, or they'll have a chart on map. Personally, my opinion of that is the map is useless in that occasion. I know where Atlanta is. If you just said Atlanta and you put the chart next to it, it was just as good as a map because the geographical context had nothing to do with what I had on that chart. Yes?
So there are examples of where you want to do that, like you look at voting.
Correct. Correct, because that is important. Again, I said, be careful, not don't do it. Next chart is don't do it. What charts to avoid? Where do I start with this? As you can tell, I'm not a big fan of pie charts. For many reasons. Typically, pie charts tell me a story that I already know. And more importantly, they don't ever tell me the whole story. It shows parts of a whole, which I could have done in a bar chart that I could very much see that a lot more clear. So with pie charts, especially if there's too many slices, it's very hard to see the values or what the percentage of a whole, unless I put in the numbers. Then it becomes an attentive attribute anyway, instead of a pre-attentive attribute. But more frequently, it tells us a story that we already know. The classic example I like to use, I actually did this the first time with a customer in Germany, and it was, BMW, right? So BMW has three main series of cars. They have a 3 series, a 5 series, a 7 series. If I had to do a bar chart, right, and I want to see the percentage of sales for each series, obviously the 3 series would be the biggest slice and the 7 series would be the smallest slice. Pie chart didn't tell me anything I didn't know. What might be more interesting is, what was it versus Target? What was it versus last year? Or how am I comparing to Audi? Or how am I comparing to Mercedes? Because that is a story that I do not know and would be much more interesting. We'll talk about it in a little bit more detail. Gauges, thermometers, cylinders. They're pretty as heck, but they're absolutely useless. All a gauge will tell me is one number. Sometimes it'll tell me how close I am to my goal to some extent, but I could do that in a bullet chart. I don't need. The problem with gauges is it uses a lot of real estate. But thermometers and cylinders are completely useless, right? Give me a little bullet chart, I could do that much easier. It really, sometimes just having the number is enough. A number and a color, a number and a trend, a number and something else. It's not very useful charts. Yes?
In terms of pie charts, it's a general subject. The drill down concept can be very useful. So not only in pie charts, but in anything where you want to show something on a approximate scale. So
Yeah.
there's a pie chart divided up into 4
Yeah.
components. Then you have a drill down of the one, and that one divides down into further. So you have like
Why not use a bar chart?
Well, I'm saying for a drill down.
I could drill down on a bar just as easily as I can on a pie.
That's why I said drill down can be applied to anything.
Anything. That is.
Space for a pie chart, it takes up less space. And I agree with you, this many values is absolutely useless. If you're showing a basic comparison, that gentleman said there, and you've got very little space, and you're doing a dashboard, and you sometimes have their places, and there's a lot of changes.
There are certain use cases, they're very rare. They're very rare where they're useful. They're very rare where what I really want to know is a percentage of a whole, where that piece of information. There are two examples I will give you where that is very useful, where percentage of a whole is important. And sometimes, and some of these things would be very surprising to me. One is, and you have to do this right, so anybody who's done any kind of investment, so if I have, what kind of risk I'm tolerated, so if I want a growth income, so there's a pie chart that says, well, if that is, I need 20% of cash, 40% of that, so the percentage of a whole is really important, and then usually what you should be doing is having what the actual is and what the, and then what the goal is. But even then, if I did it as a bar next to each other, it would be a little bit useful. The other example, percentage of a market share, right? So if I asked you, browsers in industry, what's the percentage of Chrome versus Firefox versus Opera versus IE? I was actually surprised. So what's the number one browser in the market? No, IE. IE is the number, if you do based on numbers of browsers, IE is still unfortunately number one in the market. See, that was very surprising to me because I said, who the heck uses IE anymore? It's a piece of crap. But it is still the number one browser in the market, if I'm not mistaken. The last time I checked on...
So I mean, heck, literally, I looked this up yesterday.
Yeah? How close is it?
And surprisingly, IE is still holding on, especially because of 10, but Chrome is clearly the winner and it's growing. The only reason IE is still holding on is a lot of corporate systems.
Correct. Correct. A lot of crop, then that's so then it must be very recent, because the last time I checked was last year, IE was still number one.
It's only about 14% last year.
Yeah. What's that?
I didn't hear what the other one was.
IE and Chrome are the two biggest browsers in the market today. What's that? Yeah. All right. Data ink, data pixel ratio. This is another one coined by Edward Tufte. The idea is let the data do the talking, right? So basically reduce any non-data pixels, whether it's grid lines, axis lines, background decoration, colors, fills, gradients. Let the data do the talking. Use colors when it's necessary. Don't use gradients. It's very funny because I remember one of the first charts that I thought that I built that was really cool was a 4D bubble chart, and each bubble had a gradient, so it looked like a shiny ball, 3D. It was probably the most beautiful chart I've ever designed in my world. But it's not the right way of doing things. Pretty, yes. And again, eliminate unnecessary pixels, illustrations, meaningless colors, logos, borders, which leads to my next. Anybody here travel and get the USA Today? They always have on the bottom left a chart like we have on the right. So Edward Tufte takes a very hard line on what he terms as chart junk. And a lot of these things are chart junk. Basically, there's a lot of it out there. But recent research shows that judicious illustrations and design elements makes people recall what it is. What typically happens, people see the chart on the left and they see the pretty girl. People see the chart on the right and they see, oh, in 1980 there was a lot of people who bought diamonds, and since then it's been declining, right? So that's the kind of thing that you see. So what is chart junk and what isn't? What definitely is, again, 3D effects, unless 3D dimension is meaningful. If you do like a third dimension on the chart, gradients and textures, distortion, watermarks, what might not be but sometimes are, icons, illustrations, unusual color treatments, unusual type treatments, like and dot comparisons. Unless it's adding to your story, do not use them. And who is the leading pusher of chart junk? What's the leading source of chart junk? Anybody give a guess here? Thank you. Microsoft actually Excel. So these are all the different charts you can use in Excel. These are all the charts you could use in Excel. And almost all of them are absolutely should never be used. All right. Using color. Again, use desaturated zones. Reserve bright, highly saturated color for emphasis, like red. Warm colors should appear in the front. Use contrast, use the other sides of the color wheel. Chart furniture should go with very light monochromatic lines, so like a light gray. Soft color backgrounds or white, or even negative space for grid lines could be very effective. Yes?
So you said that pie charts are a bad representation of, you said don't do pie charts.
Correct.
Then you have a pie
That's
chart.
not a pie chart, that's a color wheel.
Donut.
That's a color wheel. That's,
But it's a pie chart with it.
it's a color wheel. Yes?
One thing that I learned about many years ago is one of the problems I still see coming up is we were told what two colors not to put together. And I see a lot of violations of those rules. In other words, there are certain colors and you put them together and they don't visually separate.
You don't really separate the, ooh.
Recommendations as to what you shouldn't do in
Yeah.
the sense of color combination.
There is, and then there's the colorblind. 7% of males are colorblind, and they can't tell the difference between certain colors, which is a slightly different issue. Whether we should, well, we could get into blind but that's a different story and not for this chart. All right. Is this a good sign that my stock price is going up? Is this good? Is this good?
Yes. Unless you're mounting it up.
Well, the stock is going up. In general, it's on purpose, the numbers. I deleted numbers.
Last 5 minutes.
How about now? So if I'm comparing it to a benchmark or I'm comparing to my competitors, now even though my stock price has gone up, now it's not so good, right?
Is there really a benchmark of stocks though?
S&P 500, NASDAQ.
But isn't your perception of the stock the benchmark anyway? Does that make sense? Like, isn't it built into itself?
No, not really. With stock market, it's the benchmarks. There's very specific benchmarks for stocks, for funds, for mutual funds. Everyone has different, very specific stock. Or it could be my competitor, right? Right? If I am IBM, I'm comparing my stock to Oracle or SAP. If I'm doing good, if I'm doing better than them, I'm happy, right? If you're Larry Ellison, as long as you're doing better than SAP and IBM, he doesn't give a shit what the benchmark is, right? So who you're comparing to. Another example. So this is sales of different types of toy cars, right? So if I'm just looking at this chart alone, I'm saying, classic cars, I'm doing pretty good, right? So if I'm a classic car salesperson, I'm happy. How about now? Did I hide the wrong slide? Hold on a second. Yeah, I hid the wrong slide, sorry. Control click, unhide slide. And what's the button to show this? Top what? Play? Play. Thank you. Mac. So now if I'm saying I'm comparing my current sales, 2013, to my last year's sales. Now classic cars is not doing so good because I dragged by about 50%. Motorcycles, on the other hand, has added growth. Motorcycles is kicking butt. So what does all this mean? Is when you're dealing with charts, especially when you're dealing, you have to tell the whole story. And part of that, and this is another reason why I don't like pie charts, is I don't have any comparative value. So the fact that it's a percentage of a whole, so what? Is it better than it was? Is it worse? So the fact that, going back to my story with the cars, so the fact that 45% of my sales is a 3 Series, is that good or is that bad? I don't know if I'm just looking at a percentage of a whole. Sometimes that's the only story. So sometimes the percentage of the whole is the only story, and that's okay. And then pie charts are for that perspective, is okay. But most of the time, that's not the whole story. So in these cases, usually you want to use some kind of comparative value. You want to compare it to either a benchmark, a target, a budget, and of course, one of the best ones out there, the last period, whether it's last year, last quarter, and stuff like that. Then I could actually see whether things are actually good or bad. Yes?
Labels at 45-degree angles.
Avoid them like the plague.
Well, I disagree, because it's great to have a rule like that, but there's, like, in this instance right here, this would be much more readable, the bottom labels, if they were at 45 degrees.
No, they wouldn't.
And then you wouldn't be able to
Double lines, in this case, are not necessarily that bad because I can still see juxtabuckets. I would rather you flip the chart than actually read.
There's sometimes reasons why you can't flip the chart. And if you can, I would rather have, in that particular instance, maybe we can take a vote.
Yeah?
But in that particular instance, looking at that right there, I think 45-degree angles would work really well. And then you have every label would be on a single line.
I think that's an aesthetic.
Yeah, it's an aesthetic choice. Let's leave it at that. All right, some visualization examples. This is one of my favorite visualizations. The reason why I like this visualizations is because the data is doing the talking. All I need on this visualization is a single title, and that's all. And the rest of it is the data is doing the talking. So in this case, it's U.S. unemployment level. Obviously, I could see some problem areas right away. Alaska, California, Michigan, they're having problems. Middle of the United States, they're okay, right? So I see patterns. I could see very distinctly where the specific numbers are not that important in this case. but the numbers are doing the talking. And if I was doing this right, it's actually by counties. If I click on a county, it should show me up either when I move my mouse over the county, it should show me up the detailed information, or I could click on it and it drills down to more detailed information. But this chart tells me a story, and very obvious one, where the unemployment levels are high and where they're low. Did I have to tell you which ones are the high and which ones are the low? No. What's that?
There's no legend. I can make an assumption that the dark is more probable without a legend. How am I supposed to be assured which is which?
Because it goes back to the attended product. Dark usually is a higher number than light. That's the way we perceive it. So we know this because we know Alaska, there's a lot of unemployment. But even without that, in general, our mind perceives a darker color as a higher than a lighter color. So it didn't even have to have a legend.
I'd like to use that.
What's that?
I'd like to use that.
How much what?
I'd like to use that.
That,
The darkest.
in this case? With
I'd like
that,
to use that. 10,000, 100,000.
a billion. Yes.
The one thing that's missing here that you reflect to in other cases is trends. So, how would you say you want to show how's the unemployment rate?
Oh, I love you. All right, so this is how I would design this, and this is where a motion chart would be perfect, right? So think of it. What's that? How would I? Because one of the things we keep on talking about is we want to see trends over time in a lot of cases. So how would I see trends over time in a scenario like this? And this is how I would do it. And think of it a slider here on the bottom. That's a slider on time. And as I'm moving the slider, the colors change based on the employment rate at that period in time. And then you could see trends where there have been differences of things moving over time, and that is a heck of a story to tell. And it's, again, I would actually probably have on that slider some years, but again, I wouldn't have to give any detailed numbers, any explanation of what you need to do. Yes?
I was going to say that another piece of that story that's missing is a comparison to the unemployment to the relative population.
No, this is it should say U.S. unemployment rate. So this is a rate. It's as a percentage of the population. Typically, when we're doing unemployment, we're talking about unemployment rates, not specific numbers. Otherwise, Alaska would never be that dark because there are no people. Well, there are some people in Alaska. Very few people in Alaska.
What also may be important is that it's normalized. So if there's one of those counties that actually only has, I don't know, say a low number of.
It's percentage rates. It doesn't really matter what the population of the county is.
Wouldn't that have much higher outliers just based on more random factors? It's not normalized.
Maybe. Now we're talking statistics, and that's not really my strength. Yes?
No, I mean, I think the other chart that could be useful, the other graph, is unemployment account, because that has a lot to do with surveying where my money has to go to support unemployment.
That's a different story.
Different
But
story,
it can.
I need a different chart.
A different chart, and there a chloropath might not work again because then what would happen is that Hawaii, Alaska, North Dakota, and all those would be white, right? Because the numbers are very small, and then you'd have cities, you have areas like New York and California that it would be just dark just because of the numbers.
And that's why the federal government would like to know where to put its money.
Well, federal government. All right. Another one, this is not necessarily visualizations, but this is an example. A lot of things are going these days. People are building infographics. Personally, this is more attentive because you have to read the whole infographic to understand what the story is. It looks pretty. It does a lot of different things. It's using things like over here, the repetitive, so it's showing a lot of different things over a same scale of time. So it's doing certain things and it's highlighting certain colors. So these are things that are different, but it's in French, so I can't actually read it. But it's a good example of infographics that are being popular. Another one of my favorite charts. So this is, again, the data is doing the talking. All it has is a label. It's U.S. commercial flights, 1995 to 2008. Each box is a year. Each row is a day of the week. So the top is Sunday, the bottom is Saturday. So very quickly, I could see a lot of trends. I could see that, red is less number of flights, green is a higher number of flights. I would have preferred it if they used in this one as a chloropath. I could see that Saturdays and Sundays are the least traveled days. I could see the middle of the year is the most traveled days. A lot of people go on vacation. A lot of people are traveling. Can anybody guess what this is? Okay, how about this? Notice at the end of 2008 it starts getting red. There you go. So it's interesting because the data is doing a lot of talking here, and I could see a lot of information. People travel less in the winter months. You could see that, the colors are slightly lighter and closer to red on the end of the year. Interesting, right? Very powerful visualization. Drill down is different ways of displaying large amounts of data and very specific types of information. So drill down is kind of like a tree structure where I could drill down. On the right here is a tree map. A tree map is a chart that has multiple dimensions. The color is one thing and the size is another. In this case, the size is the 2012 medal count for Olympics, and the color is the growth or lack thereof from the previous Olympics. And then if you drill down on Europe, it'd go into the countries. You drill down into a country, go into the different athletics within that. So it's a lot of different ways of looking at different pieces of information. This is one of Stephen Few's favorite dashboards. What does your eyes first get drawn into? Problems. So he's a very big fan of monochromatic colors. Colors should be used only for emphasis. You can see very quickly. And he's actually, again, he's using multiple variations of data. So here's my key metrics for sales, revenue, profit, average order size, right? These are different things. Revenue is growing, profit isn't, right? So revenue is above target, profit is above. But new customers and customer satisfaction, market share, these are all things that are below market, the things that I need to aware about. And it's also, if you notice here, there's a lot of different pieces of information in a fairly small area. He's doing that by using spark lines, bullet charts, different kind of things that he's actually showing here. Another Stephen Few example. This is a little bit too much in my opinion. There's a fine line between a lot of information and too much information. But again, it's a nice way of visualizing a lot of different information. This is just portfolio performance. Another dashboards, good color schemes. This is a nice chart that Google and Finance and Yahoo Finance use a lot with the different. I don't know what's going on. Another different way, again, another different type of bullet chart with different colors. Trends, I like to use these kind of arrows for trends. It might be doing very good, but it's actually trending down. I need to know that sometimes. Using maps for different things is also very useful. Again, use maps when it's appropriate.
What are your thoughts on those charts on the left?
They're becoming very popular. I'm on the fence with them. They're good for if I'm using a lot of them in a small site. So because in this case, there's different numbers here, right? Credit limit, retirement goals. So there's all these different things. And if I'm doing a bunch of them together, and then they tell me a story. What's that? But I wouldn't use one as it's never. It should never be a standalone. It's a bunch of them. Again, it goes to that whole thing that we're talking about is repetitive type of information. That I'm seeing how I'm doing overall by showing different information. And the other time where you want to use it is where the number is what's really important, right? It's the number that's important. It's always a single number. You'll see this always a single number, part of a chart, and when the number is important. Any other questions? I think I did my 45 minutes, a little bit more. Yes? It will be, I think, right? Where's Matthew? Yeah, I'll probably put it on SlideShare or something like that, and I'll share it that way. What's that? Yes?
Just a question of the mobile experience with charts. Is there any sort of decisions that you're thinking that could be changed for a mobile audience?
Okay, so when it comes to a mobile audience, I should actually show, if I could have worked on my chart. There's one thing you want to do with mobile charts, and that's responsive design. So if I flip, it actually changes, so I need to be aware of that. What I'm seeing most of customers who are dealing with mobile type of data visualizations is what they're doing today is they're designing their applications for tablets. Right? They're designing for tablets, and whatever works on a tablet will work okay on a desktop. I have enough real estate on a tablet that I could do most of my stuff, most of the stuff. This might be a little bit too much detail. I could do this on a tablet. I can't do this on a tablet, right? I could definitely do this on a tablet. I could do this on a tablet. I could do this I can't do on a tablet, but this I can. So depending on what I am doing, if I design it for a tablet, it'll work on a desktop. If I need to deliver my content to a phone, now it's a different story. There's the scenario where typically, like if I go to ESPN.com on my tablet, I'll go to the regular ESPN.com. It's the same one I'm seeing on my desktop. If I go it on my phone, I'm going to a different website. If you're doing data visualizations and you need to gear towards a phone, you expect people on a phone to get at it, you need to design a different website, a different type of visualization. It's just because not only is the amount of real estate a lot smaller, but also there's just so much I can see. The other thing is, and this is a more fine line with applications in general with web applications, your finger isn't as accurate as a mouse. So anything that you need to click on, you have to make sure there's enough real estate on it to click on. So I couldn't do this because I can't click on a county, right? But if I actually had a bar or a pie chart where I wanted to click on the bar, that's enough real estate. So there's just certain considerations that you have to take in effect when you're designing for mobile applications. A lot of it depends on if that's your main way of distributing your content. I think you're the guy from New York Times, right? Yeah. So.
Yeah, I was just thinking like.
Yeah. So. Because when you go to any type of news service that you have now that I have on my phone, right, you could flip through the articles, you could read through the articles. That is okay, and I could do that, but it'd be very hard for any data visualization other than one or two on a single page without clicking on it to expand it, maybe the full page and a little X to actually decrease it. So I really have to design it differently for a phone than I would for a tablet or a desktop. Yes?
What about the idea of using emotional portrayal?
Is that you asked that?
That's right. Well, I didn't give I gave an example which was actually developed in like 19.
Yeah.
But no, I'm thinking about something where the subject material is very emotional, and the charts become very complex, and you really want to convey something emotional, such as medical presentations for somebody personal, deaths, all kinds of things that are highly emotional.
If you can, the trickiest part, I have no, I'm okay with It's just think of it like an asterisk or a marker or a call out. It's part of the story you're trying to tell. The harder part, in my opinion, would be the algorithm to decide what that emotion is, right? A happy customer would be, he's got a great deal. Certain things are very easy to figure out. If there is an algorithm where I can actually decide which one of these 4 or 5 emotions I want to put on the chart, then I would do it. Otherwise, I'd be very careful with it, because otherwise it becomes chart junk. Yes?
What are some of your favorite tools for building these charts?
Oh, I work for OpenText. So anybody here of Actuate or BERT? BERT, something? No. Those are the tools I've been using for the last up 10 years. So these are very good. BERT is an open source project, part of Eclipse Foundation. So we just got, I said OpenText, but I worked for a company for 19 years called Actuate. We just got bought by OpenText, so it's a recent acquisition of ours. There are a lot of different tools for different purposes. Pure data visualizations, there's things like D3, high charts. Those are all very good. A lot of it depends on the purpose of the application. Our tools are very targeted to developers who need to deploy these visualizations to large populations. That's what we do better than anybody else. There are tools out there like Tableaus and Clicks that do more of data mining and data visualizations. They're more for the business users to be able to do their stuff. So there's a lot of different things. Obviously, I think Actuate is the best thing since sliced bread. Otherwise, I wouldn't be working there for 19 years. Any other questions? All right, I think beer is called for right now.